The James Webb Space Telescope, also known simply as Webb or JWST, is a groundbreaking scientific tool that has revealed astonishing details about stars, planets, galaxies, and other fascinating cosmic phenomena, setting new standards for scientific discovery. Often celebrated as the successor to the iconic Hubble Space Telescope, Webb has captivated people worldwide, with enthusiasts sharing images or using raw data to uncover new insights. Just 1 year has passed since the powerful telescope unveiled its first historic image of the universe, stunning astronomers around the globe with its incredible detail. However, Webb's latest discoveries present a surprising, even unsettling glimpse of the universe, one that raises more questions than answers for scientists. Join us as we explore how the James Webb Space Telescope has captured some of the most astonishing images in history. A month after releasing its initial photographs, JWST revealed new information about star formation, galaxy mergers, and the early universe. The images showcased breathtaking details, providing scientists with a treasure trove of data that has led to a surge in discoveries. Observations made by the telescope include images of cosmic tarantulas, record-breaking stellar nurseries, stars on the brink of supernova explosions, and other incredible celestial objects. Thanks to Webb's advanced technology, we can now see farther into space than ever before, uncovering previously unknown facts about the universe. The first year of the telescope's operations marked a new era in astronomy, with NASA commemorating this milestone by releasing a new image that showcases a small star-forming region within the Rho-Ophiuchi cloud complex. This image captures jets from newborn stars, with massive clouds of dust in various colors surrounding them. Glowing red dust is composed of molecular hydrogen, and shadows from circumstellar disks hint at potential planet formation. While the scene might look chaotic, NASA describes it as a relatively peaceful stellar nursery compared to others. Many of the young stars in this area are similar in size to or smaller than our Sun, making this region the closest star-forming area to Earth. This image was captured by the telescope's primary instrument, the near-infrared camera, an IR-cam, which can simultaneously capture cosmic images in 2 distinct infrared ranges. Webb has also enhanced our understanding of exoplanets, worlds that orbit stars other than our Sun. The observatory has proven particularly adept at studying large exoplanets, and in early 2023, it identified its first exoplanet, LHS 475b, located about 41 light-years away with a diameter close to Earth's. NASA highlights that Webb is currently the only telescope capable of analyzing the atmospheres of Earth-sized exoplanets. The telescope's discoveries extend to ancient galaxies that, according to existing theories, shouldn't have formed. An international team led by Evo Lab from Swinburne University recently identified 6 massive, old galaxies, nicknamed universe breakers, which could revolutionize our understanding of the cosmos. These colossal galaxies may have emerged between 500 and 700 million years after the Big Bang, according to the researchers' findings. Webb's infrared sensors, which can look back roughly 13.5 billion years, helped scientists observe stars and galaxies in their younger stages. The sheer mass of these universe breakers has left scientists bewildered, as galaxies in the early universe were expected to be 10 to 100 times smaller than these enormous structures. It is estimated that these 6 objects could be billions of times heavier than our Sun, and the total mass of stars in a single galaxy might be 100 billion times greater than the Sun's mass. The idea of comprehending something so vast can be mind-boggling. Though most galaxies from this period are relatively small and grow only gradually, a few massive ones seem to reach maturity far more quickly. How this happens is still a mystery. Joel Leha, an assistant professor of astronomy and astrophysics at Penn State University and co-author of the study, expressed his astonishment at the discovery of a new class of objects that formed at the dawn of the universe. This revelation challenges many long-held beliefs about cosmic evolution, suggesting that the formation of large galaxies began much earlier than previously thought. As Leha remarked, this discovery is so unusual that it has created challenges for the scientific community, casting doubt on existing models of early galaxy formation. Further validation is needed through spectrometry, which separates light into its component wavelengths, allowing scientists to obtain precise distance measurements. Only a few recently discovered objects have had their distance and mass verified. If the data holds, it suggests that galaxy formation had to occur much faster and more efficiently than previously thought. The fact that spectral data has supported these findings is promising, yet the implications are so groundbreaking that scientists remain cautious. Astronomers have long sought to unravel cosmic history, so it's no surprise that conflicting data from telescopes can create confusion. Cosmologist Dr. Katie Mack recently shared insights into these perplexing findings, noting that JWST has provided evidence of galaxies that appear to have started forming much earlier than scientists anticipated. Yet, as Mack pointed out, the telescope is capturing images of galaxies more than 13 billion light-years away, which are understandably somewhat blurry. There doesn't appear to have been enough time since the Big Bang for these massive galaxies to have formed based on the telescope's dating results. This is concerning for many in the field, as it casts doubt on various theories, including those about dark matter and the Big Bang. However, more evidence will need to be gathered to draw definitive conclusions. JWST is capturing images that could reshape our understanding of cosmic history and open up new possibilities in space science. As it continues its mission, it's clear that the James Webb Space Telescope is on the verge of uncovering truths about the universe that were once beyond human reach. Researchers are eagerly anticipating insights into the extraordinary atmospheric composition of the gas giant Uranus, hoping that the James Webb Space Telescope, JWST, can reveal details no previous telescope has been able to capture in infrared light. Unlike the Hubble Space Telescope, which only detects visible light, the JWST's infrared imaging allows a deeper examination of Neptune and Uranus, revealing previously hidden depths and features. Recently, JWST captured phenomenal footage of a star nearing the end of its life. In late 2021, it provided an unprecedentedly detailed image of the massive dying star Wolf-Rayet 14. Located approximately 15,000 light-years from Earth, the star was captured in the process of ejecting gas and dust into space. The resulting image, provided by NASA, showcases a glowing purple remnant of the star's outer layer, a dusty and gaseous shroud that causes it to flare with intensity. This vivid image represents a significant improvement over a 2015 Hubble image, which, due to technological limitations, showed a less detailed, blazing ball of light. In JWST's view, the dramatic effects of Wolf-Rayet 14's shedding process are now clear. This colossal, decaying star, found in the constellation Sagittarius, is estimated to be several times larger than our Sun and has ejected enough gas and dust to envelop about 10 suns. According to NASA, the starlight captured in JWST's image has been traveling across the universe for 15,000 years to reach the telescope. The dust encircling the central star is a byproduct of this shedding process. As stars die, they release their outer layers into space, forming material that can ultimately create new planets, a process that underlies our own cosmic origins. Scientists believe that Wolf-Rayet 14 is on the verge of a spectacular supernova explosion. In another astonishing discovery, JWST captured the haunting image of an intense star-forming galaxy. Initially observed a decade ago by a ground-based telescope, the galaxy Aztec 3, also called C71, vanished when the Hubble Space Telescope attempted to study it in more detail. However, with JWST's advanced capabilities, this elusive galaxy has been rediscovered. Artist renderings depict Aztec 3 as a cosmic entity with two eye-like structures and a gaping mouth, giving the impression of a monster in space. The galaxy, with a redshift of around 6, is thought to date back roughly 900 million years after the Big Bang. Despite its small mass, Aztec 3 is responsible for forming numerous stars every year, suggesting that star-forming regions may have been 3 to 5 times more common in the early universe than previously believed. JWST's unprecedented sensitivity has opened up the possibility of observing countless galaxies previously obscured by cosmic dust, which absorbs starlight and re-emits it at longer, redder wavelengths. Dusty galaxies have been challenging to capture until now, as the optical instruments of the Hubble Space Telescope could only see dust-free regions, skewing our understanding of galaxy formation. However, JWST's infrared capabilities now allow astronomers to pierce through dense dust, reaching even the most concealed regions. JWST is also making discoveries closer to home. Its high-resolution images of Mars taken last year, have allowed scientists to study more transient phenomena on the planet, such as dust storms, weather patterns, and seasonal changes. However, observing Mars presents unique challenges for JWST, as the planet's intense infrared light can overwhelm the telescope's instruments. To address this, astronomers employed specialized data analysis techniques and extremely short exposure times. The scientists involved in these findings are now preparing to analyze spectroscopic and imaging data further to deepen our understanding of these remarkable cosmic events. The Webb telescope offers breathtaking close-up views of nebulae, yet shows distant galaxies as faint, almost fluffy specks. This is due to how different colors are influenced by various parts of the light spectrum. Webb can detect light from a source in two distinct ways: by spreading out the light using a spectrograph, similar to a prism, and examining the brightness of each color, or by using filters that block all but a select range of wavelengths. With this data, scientists can calculate the galaxy's redshift, which indicates precisely when in cosmic history the light we see was emitted. Interestingly, some galaxies display an unusual abundance of stars, or stars that seem too young for the time they originated. This has led to several theories. It's possible that the photometric data was slightly off due to telescope calibration issues. Alternatively, Webb may have observed a cluster of galaxies that aren't representative of the norm, or cosmic models for nearby galaxies might not accurately apply to those much further away. If these distant galaxies are indeed as large as they appear, it could mean that previous estimates were mistaken, possibly requiring a major revision of our understanding of cosmic evolution. This isn't the only area where discoveries challenge current theories. For example, astronomers have been puzzled by the discovery of a planet seemingly too large to exist according to our understanding. Research from Penn State found a planet more than 3 times the mass of Earth orbiting IS 354, an ultra-cool star with much less mass than our Sun. This finding suggests that even around small, cool stars, substantial planets can form. Scientists previously believed it unlikely for enough material to accumulate around such low-mass stars to form large planets, yet here it is, prompting a re-evaluation of theories on both stellar and planetary formation. A helpful analogy might be to compare stars to a campfire. As the temperature drops, you must stay closer to the fire to remain warm. Similarly, planets that need to retain heat and support liquid water must orbit closer to cooler stars. If a planet orbits tightly around an ultra-cool star, the gravitational pull can slightly alter the star's spectrum, causing tiny shifts in color, which astronomers can observe. Meanwhile, a stunning new image of Uranus, showing nearly all its dusty rings, which have been challenging to capture until now, was taken by the James Webb Space Telescope. Previously, only Voyager 2 and the W.M. Keck Observatory had managed to photograph these fainter rings. Webb's image demonstrates its remarkable sensitivity, revealing 11 of Uranus's 13 known rings. Unlike Saturn's flat rings, Uranus's unique tilt causes its rings to appear vertical. The 2 outermost rings were undiscovered until Voyager 2's 1986 flyby, as their dusty composition made them difficult to detect. 9 main rings were known before then, and in 2007, the Hubble Space Telescope captured images of 2 more faint outer rings, which are not visible in Webb's photo. According to researchers, a planet's ring system can offer valuable clues about its formation and early history. Uranus is an unusual planet with an inclined orbit and an absence of internal heat, making any data about its history especially valuable for understanding this enigmatic world.